Hello everybody. I'm going to work with you today on solving a system of equations. One is a linear and the other one is a quadratic. We'll take a look at it and see what we can come up with. We'll eventually go to Desmos and take a look at it there as well. All right, so what we're looking at here, we have a linear on the top here, we have a quadratic at the bottom, the second equation, and there's a couple ways we could look at doing this. I'm going to put it up here in the little scratch pad here and discuss options. One option would be subtraction. I would subtract in that direction, or I say elimination. You could subtract them. Y minus y, you get a 0. X squared won't combine with anything, which is okay. This guy won't. He will combine with this. But I think substitution might be the easier way, because remember back when we solved systems, we can also use substitution, and this is really set up for it because you've got an isolated variable. It happens to be y, so substitution works out to be pretty good here. So I'm going to go with that. So to use substitution to solve this, you'd have to write negative 3x minus 8 equals x squared plus 5x minus 28, right? And now we're going to combine what we can, and we're going to solve a quadratic, so we need to get 0 on one side. And remember, to solve quadratics, we've got the quadratic formula, we've got factoring if applicable, and if we don't see how to factor it right away, I just go to quadratic. So I'm going to add 8 to both sides, because remember, I want to get 0 on one side, and I'm going to add 3x. I'm doing this all in one step because I don't want to rewrite it so many times because I'm going to run out of space on my little pad here. So I've got 0 equals x squared plus 8x minus 20. Now, if I say factor, I like to factor them if they're easy. And when I look at this, it looks pretty easy to factor to me. I need to multiply to negative 20, add to 8, negative 10 and 2 do that. So I'm going to factor it. If you went to the quadratic formula, that would be fine. I just think we're going to be a little faster factoring. And we got a positive 10, negative 2, and now we need to set them equal to 0. So we get x is equal to negative 10 and 2. Now, if you remember, the solutions to systems of equations are ordered pairs. So what we have here is the x coordinate of two ordered pairs. Okay, so let's find out what the y coordinates are. And we'll start by plugging negative 10 into one of our equations. And I think that it's pretty clear that the top equation here is the easier one to plug that 10 into, or that negative 10. So I'm going to say y equals negative 3 times negative 10 minus 8. So I get 30 minus 8, which is 22. So one of my ordered pairs is negative 10, 22. That's a solution. All right, the other one, I need to plug that 2 in. So we're going to say y equals negative 3 times 2 minus 8. We get negative 6 minus 8, and I think that's negative 14. So the other one, I got to move my own box out of the way here, is 2, negative 14. And let's circle those so we can see clearly what the solutions are. Let's get kind of messy. So you've got two solutions here and here. All right, if you didn't like that, I have something for you. You're going to like this a whole lot. All right, so if you're not an algebra person and that was just really something that you thought was ridiculous, that's okay. I'm going to show you another way to do it. So another way to do the same set of equations is plug it into Desmos. Okay, so the top one isn't on the top. I reversed the order in here. I didn't realize I'd done that. It doesn't matter. It won't matter at all. And I'll tell you what, before I even start, I'm going to reset that back to its home setting. I'm going to graph them. So there's your quadratic. There's your linear, and what you're looking for is the intersection. All right, now, there's one of them. There's that negative 10, that 22. There's the other one, 2, negative 14. How easy could it get, right? So that's a simple way to go. Now, the problem with that graphing technique is, if I was to go to like level 3, what's going to happen here? Well, because that's a level, I think that's a level 1. Level 3 probably has, not complex, level 3 would probably have irrational solutions. So, and if you were working in Delta Math, it wouldn't take a decimal approximation possibly. I didn't give you any like that. Before you go, I want to talk about another type that can happen. And I would solve it directly in Desmos. What if we had that quadratic and we also had an absolute value? Maybe it's an absolute value function or equation here. It says x plus 6, right? And look, you solve it the same way, guys. Graph, and now in this case we'll have decimal approximations. But what I'm showing you is you can graph your way out of these sort of oddball systems of equations in a lot of cases. I wanted to work one by hand for you here with that quadratic just to show you that they're very manageable, just using the tools you learned in Math 2. But anyway, I hope you find this video healthy. Yeah, I hope it's healthy, but I hope it's also helpful. I only gave you 5 of these to do, and they're a practice grade. Graph them, and I think you'll be good, okay? All right, thanks for watching.